In this video, we're going to be talking about characteristics of functions. And then we're going to do a few examples where we're going to determine if the information we've been given allows us to say if the information represents a function or if it doesn't. So let's go over the characteristics of a function from set A to set B. So first, each element of A must be matched with an element of B. Next, or second, some elements of B may not be matched with any elements of A, and that's okay. The third characteristic is that two or more elements of A may be matched with the same element of B. And the fourth characteristic is that an element of A, the domain, cannot be matched with two different elements of B. Now, our set A is the domain, and our set B is the range of a function. So let's do some examples and see if we can't determine, using the characteristics of a function, if what we've been given is a function or if it doesn't represent a function. So let's start with letter A. Here we have a set of ordered pairs. So our X would represent our set A, and our Y would represent our set B. So the characteristics are nice, but sometimes they can be hard to understand. So this is my word of advice here. When you're given a set of ordered pairs, or if you're given a table, look at all of the X values. If any of them don't repeat, if there's no repeaters, then you're fine. It's going to make a function. But if there's a repeater, that's where you need to look a little bit closer. So if we look here at our numbers, we see that we have some repeats right here with the 4s. Those repeat. So it can only be a function if their y's are identical. So what we're going to do is we're going to take a look at the y's, and we see that they are in fact equal. They are the same thing. They are identical, which means that yes, this is a function. Let's take a look at another example. So here we have, let's move that up. In B, we have a table of values. Now again, our X's will represent our set A, and our Y's will represent our same B, our set B. Now remember that we can use what we just talked about on that last one. Just look at all of the X's. Do any of them repeat? Looks like we have repeaters here at 4, and then we have repeaters again at 7. So let's compare first our 4s. So we'll look here. Oh, it doesn't even matter if the 7's matched, because when we compare our 7 and our 8, we see that they do not match. Do not match. Which means that this does not represent a function. And the reason is because each input is only allowed to go to one output. And here we have 4 going to 2, to 7, and to 8. So let's go ahead and let's take a look at letter C. Here it's a little bit different because it's not a table, it's not a set of ordered pairs. So what we need to check first, does everything in our purple box go to everything in our kind of tan box? So does everything from the time of day box go to something in our temperature box? So our time of day is our input and our temperatures are our output. So let's look. So we see that each one has something that it's going to. So what we want to do is we want to make sure that there is only one line coming from each of our numbers. So if we look at each number, one line, one line, one line, one line, one line, one line, and none of them repeat. And so yes, this is a function. It doesn't matter that both 4 and 3 went to the number 15. That doesn't matter. All that matters is that none of the numbers repeated in our time of day box and went to different numbers. Let's take a look at letter D. Letter D is a little bit different. So here it looks like we have two equations, except that one stops. So if we look here, we have one equation, but it stops. And then it picks back up right there. Notice that on our first equation, right here, we have an open hole, right? But on our second equation, we have a closed hole. So when we see a picture of a graph, in order for it to be a function, it needs to pass the vertical line test, which means if I were to take a straight line, let's see, and if I were to move that line vertically, let's try that again, and if I was to take that line and move it vertically throughout, that it's only going to touch each function one time. Now right here, when we get our line really, really close to those dots, it only is going to work if I move that line on top of those points. If when these points stack up, there's one open and one closed. If they're both closed, it will not work. If they're both open, it will not work. It's also important that as we look at that, we see that they line up with the same number. We can't have a big gap where maybe if we were looking at another one, we had our first one that went like this, and maybe our second one went like this. We see that here we have a huge gap, which means that nothing is represented there. So that also would not be a function. But with the picture that we have here, in our example, we see that we do have an open circle and a closed circle, so an included and a not included, and they happen at the same points. So that allows us to say that yes, this is a function. Let's take a look at this next example we have. So again, here we have a graph. So we want to take that vertical line again, and we want to move that line. And as we move that line, we see that it's only going to touch our function, our line, in one spot, right? Our equation in one spot each time. And so what that means, and that there's no gaps, right? So what that means is that this is a function. It's also important to note that there are arrows on the ends of our line that says this keeps going, so it will represent all numbers. Now, what if you're given equations? Well, if you're given equations, it's going to be a little bit different than just looking at it. You need to get the y by itself first. So for letter F, we have x squared plus y equals 1. So we're going to subtract the x squared over to get the y by itself. So we're looking at y equals negative x squared plus 1. Now here, if we go to graph this, we're going to see that it's going to make a parabola, and that would pass our vertical line test. And also we know that each number that we put in right here, any number we put into our x spot, is going to give us a y spot. So if I put in a 2, I'm going to get a negative 3 for my y. No matter what, every single time I put in 2, that's going to happen. And so yes, this is a function. Let's look at letter G. Here we have negative x plus y squared equals 1. So we already know we need to get the y by itself. So we're going to add 1 to both sides. Oops, add x to both sides, rather. And that's going to give us a y squared equals x plus 1. But now we need to get rid of that square. So what we're going to do next is we're going to square root both sides. And when we square root, that means that we're going to get a plus or minus the square root of x plus 1. So what that means exactly is that if I put in a 3 here, that's going to give me a positive 2 as an answer and a negative 2 as an answer, and that's not okay. We already talked about how every input can only have one output, and here it has 2. So this is not a function because the input has 2 outputs. And so that's how you can determine if an equation or a set of points or a graph or a table represents a function.